Hey everybody, it's Matt Powers. Welcome to my laboratory. I am looking at an extension of EM, but also a combination of a bunch of other different things. It's my biofertilizer blend, but I have EM in it. Effective microbes is what EM is. EM-1, you've probably heard of that. It's a trademark term for these microbes that are absolutely incredible, but they're also microbes and they're ubiquitous. So you'll find them in the environment around us. I've got, this. Oh. So that's 5 gallons. It's actually, the top is expanding and rising because it's so active. And I was showing this brew, it's only a week old. I was showing this brew to my regenerative soil microscopy class. They're in week 17. And so they're doing biofertilizers. And it's all about establishing a baseline. It's all about establishing a point of comparison. And a lot of folks will do an extension of EM-1. And let me explain these things first. So EM, they're selected endophytes that are also saprophytes. So endophytes are microbes that live inside plants, and they're beneficial. And it's like we've got a gut microbiome. Plants do too. So EM is a collection of this, and you can add to it. You can make your own. They're biofertilizers. And so they're yeast, they're lactic acid bacteria, lactobacillus, and provolone sulfur bacteria, Rhodocytomonas palustris. And so they're these incredible microbes. I won't go too deep on those microbes right now, but I am adding, like pure cultures of provolone sulfur bacteria to keep that going in my brew, because as we brew and extend, it goes down. So you might get a bottle of EM-1 or EM Pro from Terraganics, but you got to extend it to activate it. So extending it is when you feed that EM sugar. Mostly people do molasses, but you can do brown sugar or jaggery or lots of really anything. I know stories of the beginning days of EMs that spread all over the globe through EM Row and Dr. Higa. And Richard Kamalvathan was telling me that they were using melons. So just melons, smashed melons for the sugar source in extending EM. So it can be almost anything. You can be creative with it. And so you feed it a sugar source, and then it extends it and wakes it up, and it goes from that dormant state to a really active state, and it's really incredible. And it has a signature smell. You know it when you know it, and it smells a little bit like a molasses beer combination. It smells a little bit like that. And it can kind of oscillate to more beery and then more molasses, but it's all within that paradigm of using edible, food-safe microbes. Lactic acid bacteria, we're using that in pickling. Yeast, we're using that in ferments. Alcohol, all sorts of ferments. And provolone sulfur bacteria. If you look at all the most expensive probiotic drinks, you'll find provolone sulfur bacteria is an ingredient when you test it. So it's also ubiquitous everywhere, in the world. It's a ubiquitous endophyte, but it's also like in manure lagoons, and it's an extremophile. So these microbes are really good at decomposing really difficult things, even petrochemicals and sewage. But they can go inside plants and then benefit plants and help them handle their nitrogen synthesis and sugar, turning it into, long chain carbohydrates. So it's beneficial rather than simple sugars, which attract pathogens. These microbes are part of the way that they do that. They're part of the way they're the microbiome of the plant. So us bringing these in is extremely powerful. And so I love EM. I love EM-1. Let me grab this. EM-1, we did a promotion together, Terraganics and I. We did this promotion for our future in our soil last year. We're going to do something together this year. I just know it. And Pro EM-1, this is something I use. This has Lactobacillus plantarum, Lactobacillus casei, Lactobacillus bulgaricaris, Lactobacillus fermentum. So they have a lot of varieties of lactobacillus that they list. When I DNA tested it, had even more varieties. This is an incredible addition to anyone's arsenal for growing plants, for working with soil, for growing really, really good food, for dealing with problems as well, because it's immunological, because it's part of their immune system and their digestion. It's truly an incredible product. It's an incredible solution to so many problems and different things. I mean, you could just be adding EM where there's excess nitrogen. You know, you could be just putting it in your chicken yard, you know, where it's stinky, and it literally will transform that nitrate and ammonia into amino acids and then take the smell away. So it's so powerful. It's also so simple. This is something that you can get and you can add sugar source to, and then brew and then use. And then all these solutions come from using it in different ways. So what I have here, and how is it different? Well, I was getting purple non-sulfur bacteria, Rhodosotomus palustris, in a pure culture PNS Pro Bio before they made the new improved formula. Not improved for us, unfortunately, but that guy's market is for aquariums, and he's trying to protect his market. Someone kind of spooked him and was like, I'm going to brew it myself. I'm going to extend what you got going. And he got really freaked out. So I've got a little bit of it left, but the pure culture, we're going to have to find someone else to get it from, unfortunately. I know some people are DIY doing red microbes that they're likely purple non-sulfur bacteria, but I don't know if they're exactly Rhodosotomus palustris. So I add that PNS Pro Bio sometimes, and I think of these things as like training wheels. And so I do water kefir, which has lactobacillus and yeast. And so adding those in adds those key ingredients back in. And I also do biochar dust. I also do rock dust. I used to do Super Cera bioceramic. I have bioceramic beads in there, and maybe this one. If I shake it, we'll know. Some of them have them, not all of them. I have a bunch of these 5-gallon barrels that I use. I've added EM Pro. I've added EM3, which is the purple non-sulfur bacteria ingredient when making EM1 traditionally. Right, it's crazy. EM3 is used to make EM1. I've done EMX Gold, which is a prebiotic for EM microbes. And then I've done N Humate, which was really stimulating from Bokashi Earthworks. Yeah, and then every once in a while I'll do bird guano or bat guano in the mix, and all these things I do sometimes, not always. Sometimes I'm just literally adding sugar and water and just restarting it and leaving 15 to 20% still in the barrel at the bottom. And so I'm adding the rock dust, I'm adding the biochar, and what it's doing is building up this anaerobic, sediment layer, sludge layer. Purple non-sulfur bacteria can live there and eat there, and it provides food, habitat, trophic cycling, and I've done it this way, and it's really powerful. The small surface area, well, the large surface area, but the small particle size of clay, people know how stimulating that is. We know how powerful that is. But it's the same thing with biochar dust, same thing with small humic compounds. It's the same thing with rock dust. The small size has a huge surface area, and then has a huge energetic effect, and has a huge effect on microbes. So I have that going as part of this. And I've done molasses mostly, but I've also done brown sugar. And I haven't done melons yet. That's maybe I'll just do that for fun one of these times. But I don't know how I'd get it through the spigot. You know what I mean? I have to juice everything. That's a little bit more work. But I do extensions of this, and folks kind of know what an extension of this looks like. But I'm always kind of leaning harder into things. So with my ferments, like, it's not recommended that you leave 15 to 20% of a 5 gallon. I'm talking about half a gallon to a gallon. That's crazy high numbers of mother culture for an extension. And people will be like, well, Terra Organics, if you just do what they do, you save a lot of money. But mine is like really, really vibrant. And so this is just how I do it, because I really want to maintain the personality, because I keep doing extensions. A lot of people are going to buy this fresh each time, do one extension, because that's what they recommend. I'm doing all this extra stuff to keep my extensions going, but I'm just adding little bits each time, like training wheels is what I was calling it this week. And it helps guide it, but I'm also checking on it. I'm also looking at it with a microscope camera, and we can do that right now. All right. So typically what happens with EM in general is you have a lower layer and a mid layer and upper layer. And that upper layer is going to be dominated by yeast, because yeast flakes float, and their yeast flakes are simply colonies of yeast. And so we'll see that right now. But just so you know, if you get a brew that's super high in yeast and then one that's not, they're from different areas of the barrel. It doesn't mean that you're not going to have a yeasty brew when you extend it. So a lot of these things are super tiny when they're in a dormant state. And so when you're adding a sugar source, they're going to just also multiply like crazy. So the exponential function, when you look at an exponential function, when you're adding sugar to do the Caro syrup exponential function in biology class in high school, remember? This is how I learned the exponential function. Bacteria just they use up all the sugar, but at the same time their population just explodes. So these are ingredients that we know. These are ingredients that we're familiar with, and we can look at them right here together now, and I can show you what to look for. And it's not hard. We're gonna just hop in here. You can see here I'm on a screen right there. I'm gonna jump in. We're zooming in further. It's just the next objective up, sharpening the image for you. See this flake right here? See this? You guys see this? This flake right here? This is yeast. And we'll see as we get closer. We're not at 400 times magnification, and we can just see, holy cow, look at that. So this is all just yeast. This is really healthy, plump, happy yeast. We're already seeing some long rods. We're not even there, though. By looking at this, the top of this is up here. We're zooming down. And then, wow. So this shows you the diversity of shapes and sizes of yeast. All these large things are yeast. Even the ovals, even the longer ones. So check this out. The small ones, like this fat rod right here, this rod right here, those are lactobacillus. Those are exactly who they're talking about. They're long rods, bacilli-shaped rods. And so they're all over the place. You can see them. These rods, this is lactobacillus. They are biocontrol. And we also see what looks like actinobacteria. And streptomyces is an endophyte, and it as well as candida are ingredients in EM. And I'm not talking about necessarily the medical grade or the food grade EM. I'm talking just about the regular EM that I've tested. Candida is in there as a known ingredient. All right, now, if we look really closely, we can see some star patterns. Some rods are connected at one point, and they kind of create a star pattern. And that is most likely purple non-sulfur bacteria. We can't definitively know unless we grab that specific microbe and then DNA test it. But we go off morphology. This right here down the bottom left quadrant, here and here, they both look like they are likely purple non-silver bacteria. But we've got, cockeye right here doing horizontal gene transfer. We've got rods, lactobacillus. We've got small, tiny rods. We've got big rods. We've got long lactobacilli. And lactobacilli, waving and bending slightly sometimes. So you got to be careful not to get it confused with actinobacteria where it's branching and more squiggly. But look how active this is. So let's actually go up and down. So this is the bottom of the slide right here. But if we go up, we can see the drop itself is just filled. So we're traveling through the drop. You can see all that bacteria. It's like snow. See that? There's spheres and there's rods. That's the bacteria. And some of these rods are really long. And those are lactobacillus. All right. And then the big fat ones that are ovals and long, like baguette shaped. Those are yeast, and you can see them reproducing. They're happy. You can also see just by the shapes of them and the insides of them that they're yeast. So this is looking good. This is exactly, here's another yeast flake right here. This is exactly what we want to see in our EM. We want to see the yeast dominant. We want to see lactobacillus dominant and policing things and keeping things in the right direction. We want to see yeast flakes. And then if we're lucky, we get to see some stars. So I've added very specific microbes over time to a brew that was already focused on them. And it's acted like training wheels. So I feel really, really fortunate. But see how this is squiggly right here? This is not. See this right here? Just look at the center and then look to the left. This right here is not lactobacillus at all. This is actinobacteria. See how it's all squiggly? And it's likely streptomyces. There's a strong, beautiful rod right there. And then right above it is a yeast forming another yeast, budding off. So everything's happy. Everything's going and growing, but it's not feverish, the activity. There's a hustle and bustle, but there's not mobbing. I mean, there's colonies forming, but they're not mobbing on food sources. There's a lot of microbes interacting with each other. What they're doing is they're exchanging DNA. They're also sometimes consuming each other or bombarding each other with different things so that they release DNA or they release nutrients to each other. But when they are vibrating against each other, that is horizontal gene transfer. They're conjugating. When they're spinning around each other and they spin off like pirouetting, kind of like in the middle right now, they were just spinning right here in the center. They're gonna look like they might do it again, but they're in each other's orbit. Bacteria has orbit, and they can hold DNA in their orbit and exchange DNA through each other's orbits. So when they're pirouetting around each other and then spin off like galaxies that almost collide, that is what's going on there. So, and then when they're vibrating against each other, they're doing conjugation, which is happening faster than reproduction. And remember, when we add sugar, we have the exponential function. The bacteria reproduce really fast, incredibly fast. And so it's faster than that. And so we know just by the numbers that they're exchanging DNA every millisecond. And so it's the way they communicate with and understand and are aware of their world around them. This is part of their sensing. And this is how quorum sensing forms. They're all communicating. So if something negative happens, or if they get pathogenic conditions or conditions where they would form a superorganism through quorum sensing to do that mob mentality. That's how they do it. It's through horizontal gene transfer. And so DNA is information, and they're communicating through using DNA. So there's a constant shift of the DNA. And this is why GMOs are so crazy, because it's like these microbes are exchanging their DNA every millisecond in response to their environment, picking up and dropping DNA. It's DNA from the environment that they're consuming and adopting and assuming into themselves. It's DNA from each other, from their orbit, and from each other internally, because they form these little microphalluses and inject each other with DNA. This is literally what happens, and they spread. And then you get this. So this is really good, though. This is really good. And I just wanted to show you an example of what good EM looks like, what really vibrant EM looks like, and what to look for with a microscope, and why it can be so valuable. I mean, if we pulled this up and it was just empty, that'd be a problem. If we pulled this up and it was behaving in an anaerobic, more pathogenic way, I'd be really concerned. And this is what it looks like. You know, this is what it typically looks like too for me. Though a student said, like, this is the most vibrant they've ever seen an EM collection or extension. And they've been doing it for years as well. But they're just extending, you know, from here and not adding more of those microbes and as training wheels and amping it up, and because that's essentially what I'm doing. So thank you for being here. Thank you for watching. I'm Matt Powers. Grow abundantly, learn daily, and live regeneratively. And if you like this sort of thing, regenerative soil microscopy is going to be starting up again soon. You can click the link down below. You can sign up now. It's all open. You can watch any part of it. You can join us in the live. It's all lifetime access, so you can go to all the lives in perpetuity, enjoy that, and be part of that, and learn the microscope alongside all these amazing people. There's a ton of alumni involved too. So once you get immersed in it, you'll see that you can see how everyone else is doing it during our lives and compare their cameras and microscopes and figure out what exactly you need and want by experiencing it. Because I teach people to connect their microscope cameras not just to screens, but to the computer, so that they can show each other in real time over Zoom with their microscope camera as their camera. So if you're interested in that, check that out. We're going to be starting up again soon, but again, you can just join us and hop in if you want. We're going over biofertilizers this week. Next week, we'll be diving deeper. Join us. It's going to be a lot of fun. I'm Matt Powers. I'll see you soon. What if you could verify if your compost was actually doing its job? What if you could verify if the inoculants, the mycorrhizal inoculants, and biofertilizers are actually worth the money spending on them? It is all possible. And it's all things you can learn in the Regenerative Soil Microscopy 20-week online course. If you want to learn how to not just understand your soil, but to see that the things you're doing are actually working, that the money that you're going to spend or have spent was worth it, so you don't get fooled again. This is the pathway. We need holistic testing, we need holistic microscopy, and we need to combine them in a new methodology, regenerative soil microscopy. I hope you join us. I'm Matt Powers. Grow abundantly, learn daily, and live regeneratively. I'll see you soon.